A square loop with each side of length L having uniform linear charge lambda, that means this rod has lambda charge density, is placed in xy plane as shown in figure. There exists a non-uniform electric field in space given as E equals to A by L x plus L I. That is how the electric field is given. That means it is increasing with positive x direction. Here A and L are constants and x is the position of the point from origin along x-axis. Find resultant electric field on the loop. L is 10 centimeter, lambda is given and A is given. Now let us find out for AB uh, the force formula is Q into E. Now Q can be written as lambda L because length L is given and lambda is a charge density. So Q can, first I am finding for AB. So F is Q into E. That is the force acting on this entire rod. That is QE. Lambda L and E is given as A by L 0 plus L because it is at 0. So I am keeping x value 0. And what do I get? I get L cancelled. So I get lambda AL. Then I am going to calculate for CD. Because in this case electric field has a single point, I can easily calculate. So I am first finishing up with the easiest steps. Q into E. Q is again lambda L. E is A by L. Here the value of x will be L. So L plus L. This gets cancelled. So we get 2AL. 2L or lambda. Lambda 2L. So both are in the direction right side. So if I add the two, I can get 3A lambda L. Now let's talk about the CB. Here only I'll do it for BC. So here we'll write, see here as we are moving ahead, the charge is also in the direction of electric field. Okay, first electric field at a single spot. If we talk about the AB and CD sides, the electric field was at a single spot. But here the electric field is varying along the length of BC. And if it is varying along the length BC, then electric force cannot be just directly calculated because here electric field is different. Here electric field was simply A by L A. If I had to put 0 here, electric field was simply A. Here electric field is 2A. So this way electric field is increasing along this length BC. So here force will be different, here force will be different, here force will be different. So we cannot find it by simple force into charge into electric field. So for this we have to first find charge over a very small portion, say df, and then I'll integrate from 0 to L. So df is dq E. Now dq means lambda dx and E is given to us as A by L x plus L. Okay, so we can find out F is equals to lambda by L A and x square by 2 plus Lx. I've already solved for limits 0 to L. In terms of x, I've already got the answer for the entire force. So we got lambda A by L and I'm putting the values L square by 2 plus L square, it is 3L square by 2. So we have 3L by 2, L gets cancelled, lambda A. And that is the force acting on this BC rod. Now there's no difference if I talk about this rod as well. Same, no? The limits will be same, the expression would be same. So you can simply say for AD as well, I can write force on AD would be 3L lambda A by 2. Or you can also write 1.5 A lambda L. Then it will be easier to add. This also is 1.5 A lambda L. So total force will come out to be 1.5 plus 1.5, that is 3 plus 2 5 plus 1 6. So we get 6 A lambda L. That is what we got. Now we can simply keep the values given to us, where A is given as 5 10 power 5, lambda is given to us 20 microcoulomb, that is 20 10 power minus 6, and length is L is 0.1, that is 10 power 10 centimeter 10 0.1 meter. Now 6 5 30, 2 the 600, 10 power minus 2. So the answer is 6 Newton. And the entire answer would be in the right direction. That is the answer to the question.